Well, hello there, Honors Algebra 2 Trig students. We are looking at section 8.5 today. With this flipped lesson, you're going to learn about how to solve equations. And we're going to start with a little definition. An equation in X is a statement that two algebraic expressions are equal. Here are some examples. 5x squared minus 6 equals 2x, or square root of 2 times x equals 9. So those are some examples of equations. And again, if I'm going too fast, you know that you can pause this, rewind, whatever you need to do. To solve an equation in X means to find all values of X for which the equation is true. All right, those values are called solutions. All right, so let's take a look at an example. If we were going to solve x squared equals 16, you know that you can take the square root of both sides, but don't forget, when you take the square root of both sides of an equation, you need a plus or minus. So you would end up getting x equaling plus or minus the square root of 16, and that's why you get 4 and negative 4 as your solutions. All right. X squared equals 3 has no solution in the set of rational numbers, but it does have two solutions in the set of real numbers, namely square root of 3 and negative square root of 3. An equation that is true for every real number in the domain of the variable is called an identity. Okay, so identity is going to be an equation that's going to be true no matter what you plug in for it. Here's an example of an identity. X squared minus 4 equals x plus 2 times x minus 2. No matter what you plug in for x, this is always going to be a true statement, so that makes that an identity. What about an equation that is not true for every single number that you plug in, but it's only true for some numbers that you might plug in, or maybe even not true for any of the numbers that you might plug in? Well, that means it's going to be called a conditional equation. So an equation that is true for only some or even none of the real numbers in the domain of the variable is called a conditional equation. So here are some examples of conditional equations. 2x minus 1 equaling 5x, and 2x minus 1 equaling 2x plus 6. All right, this first one, if we wanted to solve this equation, we could subtract 2x from both sides and get negative 1 equaling 3x. Divide both sides by 3, and we get x equaling negative 1/3. So in other words, there's only one solution for that equation. That makes it a conditional equation. All right, what about this one? 2x minus 1 equaling 2x. If I subtract 2x from both sides, I end up getting negative 1 equaling 6. The x's have dropped out. That means there is no solution, because there is no number that we could plug in for x that would make negative 1 equal to 6. Since there's no solution, again, it's going to be still called a conditional equation. In this section, you're going to learn how to solve various conditional equations. So first, if we were going to solve something like this, I don't even think we need to do this example. You know that you would, distribute the 2 here, distribute the negative 3, and so on, group-like terms, and so forth. So we're not going to do that example. I won't waste your time with that. I think you can handle any linear equation that comes along. To solve an equation with fractional expressions, you need to find the least common denominator of all the terms and multiply both sides by that least common denominator. So here's an example. To solve this, 5x over 4 plus 1/2 equaling x minus 1/2, we would want to multiply both sides of this equation by the least common denominator. Least common denominator here looks to me like 4, so we could, as a suggestion, multiply both sides of this equation by that least common denominator of 4. If I take 4 times 5x over 4, I'm just going to get 5x. If I take 4 times 1/2, I get 2. And over here on this side, If I distribute the 4, 4 times x is 4x, and 4 times a negative 1/2 is a negative 2. At this point, we've got a nice linear equation to solve. You know, subtract 4x, and we get x plus 2 minus 2. Let's subtract 2 from both sides also, and I get x equaling negative 4. All right, and you could test that in the original to make sure that it works. All right, let's take a look at this fractional equation. We've got x over x plus 4 plus 4 over x plus 4 plus 2 equaling 0. Same strategy. Look for the least common denominator and then multiply both sides of the equation by that least common denominator. So in this case, least common denominator out of x plus 4, and 1 is just x plus 4. So I'm going to multiply both sides of the equation by x plus 4. If I distribute x plus 4 times this first fraction, I would get x. If I take x plus 4 times 4 over x plus 4, I get 4, plus take the x plus 4 times 2, and I'm going to get 2 times x plus 4 equals, and on this side, of course, 0 times anything is still going to be 0. And so we could clean this up. X plus 4 plus 2x plus 8 equals 0. Combining like terms, 3x plus 12 equals 0. So 3x equals negative 12, and x equals negative 4. So that is our solution. But do you notice a problem with that? Well, the problem with this solution is that if I try to plug it in to test it, if I try and plug it in for x here and here and here and so forth, I would end up dividing by 0, and that's no good. So x equals 4, we would actually call this an extraneous solution. And in math, what that means is it's a solution that works for some equation that popped up during our solution process, but not the original equation. In other words, x minus 4 would be a great solution to this equation. It would be a great solution to this equation, or this equation, or this equation, but it does not work in the original. Okay, so it's called an extraneous solution. So bottom line for this problem is we would say this problem has no solution. Okay, the original problem has no solution, and we could indicate that with an empty set like this, or we can indicate that with empty set symbol like that. All right, now we get to talk about quadratic equations. Ax squared plus bx plus c equals 0 is the general form. You may have been used to calling that the standard form, but our textbook calls it the general form. A, b, and c are real numbers. A is not allowed to equal 0, because if a was equal to 0, this whole term would get wiped out, and we would just have a linear equation. It's also known as a second-degree polynomial equation. All right, so let's talk about ways to solve quadratic equations. First method that we want to talk about is factoring. All right, oh, let me go back. So there's 4 different ways to solve quadratic equations. There's factoring, which has limited usage, only good if the equation is factorable. Taking square roots is another method, and that one, again, has only limited usage. But these 2 down here, completing the square and quadratic formula, are good no matter what. All right, no matter what quadratic equation you have. All right, so let's take a look at these. We're going to look at factoring first. So let's do this, for example, solve quadratic equations by factoring. So if we were going to factor x squared minus 10x plus 9, we would take, well, I would recommend that you could use product sum technique, or you can use guess and check, whichever one you like better. The product is 1 times 9, so the product is 9. The sum is this middle number, that's a negative 10. So the 2 numbers that work would be negative 9 and a negative 1, I believe, because they multiply together to give us positive 9, and they add up to negative 10. So again, if you were going to do this with product sum, you could then take out this negative 10x, and replace it with a negative 9x minus 1x. And we would get x squared minus 9x minus 1x plus 9. And we factor by grouping. We get x times x minus 9 minus 1 times x minus 9. And then it's x minus 9 times x minus 1. Notice, though, we have two things being multiplied together to equal 0. That means that one of them had to be 0. So that's why we would say x minus 9 has to equal 0 or x minus 1 equals 0. And we would end up with our solutions of x equals 9 or x equals 1. All right, that's how we solve a quadratic equation by factoring. All right, let's go back. Let's take a look at solving quadratic equations by taking square roots. If we have an equation like this, 3 times the quantity x minus 2 squared equaling 9, and we want to solve this by taking square roots, we would not want to multiply this all out and say, oh, what's x minus 2 times x minus 2, x squared minus 4x plus 4. We don't want to do that. All right, that would be making more work for ourselves. So instead, the first step we should do in this is get the x minus 2 quantity squared by itself. So let's divide by 3. This 3 here divides out with this 3, and we get x minus 2 quantity squared equaling 3. At this point, we can take the square root of both sides of this equation. Again, don't forget the plus or minus. The square rooting and the squaring are canceling each other out here on the left, so we're just equal to x minus 2, equaling plus or minus the square root of 3. To get x by itself, last step is to add 2 to both sides, and so we would end up getting x equaling 2 plus or minus square root of 3. So there are two solutions to this problem, 2 plus square root of 3 or 2 minus square root of 3. Those are your two solutions for this quadratic equation. Before we go back to look at another method of solving, let me give you one last example like this. Let's give you something in standard form like 5x squared minus 1 equaling 9. This one would be another good example of solving, where solving by taking square roots would be helpful. So I would suggest we get that x by itself by adding 1 first, and then dividing by 5. And we get x squared equaling 2. And then we can take square root. What do you need to remember? That plus or minus, so we get x equaling plus or minus square root of 2 as our solutions. So this situation here, just to point out why this one was good for taking square roots, it did not have a b term. A was equal to 5, b was equal to 0, and c was equal to negative 1 in our general form. So if b is equal to 0, solving by taking square roots makes a lot of sense. Or if it's already in some kind of factored form like this, where x minus 2 quantity squared, if you see a quantity squared like that, again, solving by taking square roots makes a lot of sense. All right, so let's go back here. Let's talk about completing the square. If we want to solve by completing the square, we have this equation, and we want to basically get it to be some quantity like x minus 5 quantity squared, like that last problem. All right, so in order to do that, let's review what a perfect square trinomial is. A perfect square trinomial would be something like x squared plus 8x plus 16, or x squared minus 6x plus 9, or x squared plus 12x plus 36. So those are some examples of perfect square trinomials. Why are they so perfect? Because they can be written as a binomial squared. In this first case, it would be x plus, and it's whatever half of this number is, right, which is 4, which when squared gives us 16. So x plus 4 quantity squared for this first one. And x squared minus 6x plus 9 is a perfect square trinomial because it can be written as x minus, what's half of negative 6 is negative 3, squared is 9, so it would be x minus 3 quantity squared. And this last one, x squared plus 12x plus 36, would be a perfect square trinomial because it can be written as, what's half of 6? I'm sorry, half of 12, I gave it away. Half of 12 is 6, squared is 36, so this would be x plus 6 quantity squared. All right. Okay, so that's solving by, no, we didn't solve yet. All right, so that's examples of perfect square trinomials. So if we want to solve this one here by completing the square, our first step would be to get rid of this 1 because right now it's not forming a perfect square trinomial. So let's add 1 to both sides. We get x squared minus 10x. I'm going to leave a little room to complete the square equals 1. At this point, we want to find that mysterious number like this or this or this. So in order to do that, we take half of this middle coefficient. Half of negative 10 is negative 5. And then negative 5 squared is 25. So I'm going to add 25 here. This is now a perfect square trinomial. I'm abbreviating. But I can't just add 25 to the left side without adding it to the right side also. To keep the equation in balance, we need to add 25 to the right side as well. So the perfect square trinomial can be written as a binomial squared. It's going to be this number right here that goes in right here. So it's going to be x minus 5 quantity squared equaling 26. And now we're going to solve just like as if we were solving by taking square roots. So we're going to take the square root of both sides. What do you need to remember? So we get x minus 5 equaling plus or minus the square root of 26. And last step, to get x by itself, add 5 to both sides. So our solution is x equals 5 plus or minus the square root of 26. All right, let's try another example of solving by completing the square. This time it is 2x squared minus 5x minus 1 equals 0. Now this one, we cannot complete the square right now because the leading coefficient is not a 1. We need the leading coefficient to be 1. Like in the previous example, it was a 1x squared. We need to get this to be a 1x squared. So we are actually going to divide everything by 2. And we end up getting x squared minus 5 halves x minus 1 half equaling 0. And we want to complete the square. So we're going to get rid of this minus 1 half because that's messing things up. And so we're going to add 1 half to both sides. I'm going to write x squared minus 5 halves x. I'm going to leave a little room to complete the square equals 1 half. At this point, our process is to take half of this number, and half of negative 5 halves would be negative 5 fourths. I like to work with the fractions in this case. And squaring is nice and easy because I square the numerator and I get 25, and I square the denominator and I get 16. But if I'm adding 25 sixteenths to the left, I have to add 25 sixteenths to the right. And now we can continue. So this here is a perfect square trinomial. And that means it can be written as a binomial squared. And remember, it's this number right here that goes in right here. So it's going to be x minus 5 fourths quantity squared equaling, and we need to get a common denominator over here. So this would be 8 sixteenths plus 25 sixteenths, which is 33 sixteenths. All right, and at this point, we would want to take the square root of both sides to finish this up. Don't forget the plus or minus. We'd have x minus 5 fourths equaling plus or minus square root of 33 over square root of 16, which is just 4. And our last step would be to add 5 fourths to both sides. So we end up getting x equaling 5/4 plus or minus square root of 33/4. And if you, since they have a common denominator, it's okay to write it as 5 plus or minus square root of 33 all over 4. All right, and that would be our answer, our two solutions to the equation, 5 plus rad 33 over 4 and 5 minus rad 33 over 4. All right, so that's two examples of solving by completing the square. And let's take a look at our last method, which is the quadratic formula. And so just a reminder of the quadratic formula. It is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. In this example, the a is 2, the b is negative 4, and the c is negative 5. So we would go ahead and plug those values in for a, b, and c. So we would get opposite of negative 4 plus or minus the square root of negative 4 quantity squared minus 4 times 2 times a negative 5 all over, right? Don't make the mistake of saying, oh, it's just this much has the denominator, because that is not accurate. It's all over 2a, so that's all over 2 times 2. All right, and to solve this, we would get positive 4 plus or minus the square root of 16 minus 8 times a negative 5. I think that's a positive 40. 16 plus 40, okay, and that's all over 4. Can we divide out this 4 with this 4? That is a big no, because this 4 right here is a term, so that's no good. Cannot divide out like that. But what we can do, whoops, what we can do is we can say this is going to be 4 plus or minus square root of 56 over 4, and we can look for ways to simplify square root of 56. Square root of 56 is the square root of 4 times the square root of 14, I believe. And so square root of 4 is 2, so we get 2 times the square root of 14. So right now I've got 4 plus or minus 2 times the square root of 14 all over 4. It is okay to write this as two separate fractions, so 4 over 4 plus 2 rad 14 over 4. Is it okay to divide out these 4's here? Yes, it is. And we would end up with 1 plus or minus, we can divide out this 2 with this 4 also. So we'd have 1 plus or minus the square root of 14 over 2 as our answer. I hope that looks right. I'm sure you'll tell me if it is not. I don't think you need another example of solving by quadratic formula. And so that is it for our techniques. And I hope that you enjoyed the video. And you do have some homework problems to do from section 8.5, where you will be solving quadratic equations in various forms and using various techniques. So until next time, have a great time. And thank you for watching this video.